alcohol. So let's start alcohol. First, classification of alcohol. So what is this alcohol? Alcohol, its general formula is CnH2n plus 1 OH, means those organic compound which have a OH functional group is called alcohol. Now, on the basis of OH group, it can be classified into three types: monohydric alcohol, dihydric alcohol, and polyhydric alcohol. What is monohydric alcohol? Those alcohol which having one OH group is called monohydric alcohol. Those alcohol having two OH group is called dihydric alcohol. Those alcohol which having more than two alcoholic group is called polyhydric alcohol. Now, this monohydric alcohol further classified on the basis of hybridization. If OH group is attached to a saturated carbon, then this compound is called compound containing CsP3OH bond. Next, compound containing sp2OH bond. Here, OH bond is attached with double bonded carbon. For example, vinylic alcohol or phenol. Now, OH group attached to saturated carbon atom of an alkyl group may be further classified into primary, secondary and tertiary. I repeat again. If OH group is attached with saturated hydrocarbon, then it is further classified into primary, secondary and tertiary. In primary alcohol, the OH group is attached to the primary carbon atom. So this is the primary carbon atom where OH group is directly attached with it. Then it is called primary. Look at here. This OH group is attached with this carbon and this carbon is attached with only one other carbon. Then it is called primary, or you can say the functional group of primary alcohol is CH2OH. CH2OH, CH2OH. So, primary alcohol. Next, secondary alcohol. Those alcohol in which OH group is attached with secondary carbon atom. So look at this carbon. It is already attached with two carbon. So this one is called secondary carbon. Or you remember in this way, the functional group of secondary alcohol is CHOH. Next, tertiary alcohol. In tertiary alcohol, OH group is attached to the tertiary carbon atom. So the functional group of tertiary carbon atom is COH. Here, this carbon is already attached with three other carbon atoms. So in primary, it is attached with one carbon atom. In secondary, it is attached with two carbon. And in tertiary, it is attached with three carbon. Now, allylic alcohol. Now, what is allylic alcohol? If alcohol group is attached with adjacent carbon atoms of double bonded carbon, then it is called allylic alcohol. So, look at here. This is double bonded carbon and this carbon is adjacent to double bonded carbon. So, if alcohol is attached with adjacent carbon of double bonded carbon, then it is called allylic alcohol. Now, next is benzylic alcohol. So, what is benzylic alcohol? If OH group is attached with side chain of aromatic compound, you are familiar with toluene C6H5CH3. If you replace H from methyl by OH group, you get benzylic alcohol. So its formula is C6H5CH2OH. So in benzylic alcohol, OH group is attached with side chain of benzene. Other one is vinylic alcohol. So in vinylic alcohol, OH group is attached with double bonded So this is double bonded carbon and OH is attached with the carbon. Next, phenol. So what is phenol? When OH group is attached directly with the benzene ring, then you get phenol. Now we learn nomenclature of alcohol. So, humans and other beings are characterized by their names. Some of you must be having 2 or more names. No rules to assign these names because your grandma call you in one way, your grandmother call you other way, or your father, mother in other way, so different way. So how the other person know what is your correct name? To solve this all problem, one standard name is given by IUPAC. So for the organic compound also, the name we learn according to IUPAC. You are familiar with IUPAC, which is International Union of Pure and Applied Chemistry. Some of them are known as common name also. Look at here. In common name, mostly the name is from like alkyl alcohol. Means first we name alkyl then alcohol. So look at here. Here CH3 is methyl. So it is named as methyl alcohol. Here CH3 CH2 is ethyl. So it is named as ethyl alcohol. In common system, dihydric alcohol containing OH group at the neighboring carbon atom are named as alkylene glycol. Remember this. This is for common name. And suffix glycol to the corresponding alkene is added. For example, look at here. This CH2 represent ethylene. So name is ethylene glycol. Here the CH3CH CH2 represent as propylene according to the molecular formula of alkene. So it is named as propylene glycol. If in case of dihydric alcohol, OH group are attached at alternate position, not adjacent position. Look at here. OH, then not, then OH. Means this OH group are very far away. Then their name is corresponding polymethylene group. Look at very carefully. CH2 methylene, CH2 methylene, CH2 methylene. Total 3 methylene. So name is trimethylene glycol. In the next example, there are 4 methylene. 1, 2, 3, 4. So name is tetramethylene glycol. Triadic alcohol have no general rule in this system. Their name is glycerol because it is obtained from glyceride. Now, IUPAC name. In case of IUPAC name, we replace E from alkane by OA. So, here look at this example. It is CH3OH, and we know that the organic compound containing one carbon is called methane. So replace E by OA, you get methanol. Similarly, 2 carbon is called ethane. Replace E by OA, you get ethanol. In case of longest chain compound, the rule is that always start numbering from that side by which OH group get the lowest number. So look at this example. 1, 2, 3, 4. We start from left hand side by because by that OH group get the lowest number. Now total carbon is 4 means butane. OH group at second position. So name is butane 2 all. Next, if an alcohol molecule contains 2 or more hydroxyl group, then the prefix di, tri, tetra, etc. are used. So look this example. 2 carbon. ethane, position of OH first and second. So name is ethane 1,2-diol. Total 3 carbon, propane. Position of OH is 1, 2, 3. So name is propane 1, 2, 3 triol, or commonly called glycerol. Now some cyclic compound. So this is the cyclic compound. So in this cycle, how many carbon present? 6. So, but it is present in the form of closed ring. So it is named as cyclohexane. But OH group is attached at first position. So named is cyclohexanol. Here with OH, one side chain also present. So we give position to that side chain also. Now the name is 2-methyl cyclopentanol. Now you will try to write the IUPAC name of the given compound. Now next topic is isomerism in alcohol. So what is isomerism? Two or more organic compounds having same molecular formula but different physical and chemical properties called isomerism. They are classified into two, structural and geometrical. So here, what kind of structural isomerism are shown by alcohol? This we learn now. So here, the molecular formula of alcohol is C3H8O. It is represented in two different ways. In the first way, OH attached with first carbon. In the second, it is attached with the second carbon. Now the question is, will the compound formed in this way be different or same? Then the answer is the compound will be different because one is propane 1-ol and the other one is propane 2-ol. But both are related as isomer. And the phenomena is called isomerism. So, alcohol exhibit 4 types of structural isomerism. Out of these 4, 3 are structural and the other one is optical. And optical is a part of geometrical isomerism. So, in the way of structure, they are of 3 types and the other one is geometrical. So, first is chain, second is position, third is functional, fourth is optical. Now what is chain isomerism? Those isomerism in which the position of functional group is same but the skeletal structure of carbon atoms are different. That is called chain isomers. So look at here, this is butane 1-ol straight chain. This is 2-methyl propanol branch chain. But both have same number of carbon, that is total number 4. Now, functional isomerism. Functional isomers have same molecular formula but different functional group. So look at the molecular formula C4H10O. Now, this C4H10O exists in two ways. Here, this O is present in the form of OH, but in the next, this O is present in the form of ether. So what we learn? If molecular formula same, but structural formula different, due to the presence of different functional group, it is a type of functional isomerism. Next, position isomerism. This type of isomerism arises due to difference in the position of functional group. So look at this, here OH at the first position, but in the next example OH is at the second position. So the position of OH changed. So this is the example of position isomerism. Optical isomerism. This isomerism is exhibited by alcohol having asymmetric carbon atom. So which is called asymmetric carbon atom? Those carbon which is attached with 4 different atoms is called asymmetric carbon atom. So look at this carbon, it is attached with hydrogen, it is attached with methyl or ethyl and methyl alcohol. So this is called asymmetric carbon atom. isomerism further divided into two, dextro and levo. Dextro is represented by positive sign, levo is represented by negative sign. So, dear student, in today's module, you are familiar with nomenclature of alcohol as well as isomerism of alcohol. In the next module, you will learn about preparation of alcohol. Thank you.